a vector a bar is turned without a change in its length through a small angle d theta, the value of magnitude of delta a bar and delta a are respective. Now these two quantities might appear the same, but they are not. Let's try to understand what is happening here. There is a vector a bar, and it is turned without a change in its length. It is turned without a change in its length. So let us say that the new vector is a prime bar after the rotation, but it is essentially going to have the same magnitude. Both vectors will have the same magnitude. Okay, which basically means that delta A is going to be 0, because delta A represents change in A. And what is A? A is the magnitude. Is there any change in the magnitude? No. So delta A change is 0. So option A is not right. It could be C or it could be B. Now how are we going to find delta A bar's magnitude? For that we have to imagine a circle. Okay, for that we have to imagine a circle. You know that both these vectors are along radii of this particular circle. So let a bar be a horizontal vector. Okay, let a bar be this horizontal vector, and let me tilt it. Let me rotate it by a tiny angle. Let me rotate it by a tiny angle a prime bar, theta. D theta. Okay, so this will be my a prime bar. So this angle is now d theta. You know it. Okay, this angle is now d theta. Now by triangle law, what can I write? This is change in A, mind you. Okay, let me zoom in. This vector is actually change in A. And you have done this, you may have looked at these situations when you find out or when you define instantaneous velocity as derivative of position. Okay, that green vector is actually delta A bar. Sorry? Yeah, even for acceleration, exactly, even for acceleration. Let's say the velocity changes by a small amount. You get it, right? You get it. So by triangle law, what can I say? By triangle law, delta A bar is A prime bar minus A bar. Okay, fine. So what we want is now magnitude of delta A bar. Now how can we find the magnitude of delta A bar? Use triangle law. Sorry, not triangle law. Use cosine rule. By cosine rule, magnitude of delta A bar is, okay, so how do we find it? A squared plus A squared minus 2A squared cos theta, rather cos d theta. Okay, well, let me just stop here momentarily, not using cosine rule, because they say that the angle is small. If the angle is small, you can still arrive at that result using cosine rule, but if the angle is small, okay, arc length can be approximated as the segment length. You must have used this approximation also. So we actually want the segment's length, right? That will be the magnitude of the vector delta A bar. But now for arc length, we can use the formula r theta. R radius is A, angle is the d theta. Okay, so for very small angles it will work. So A d theta will be the change in the magnitude of, well, magnitude of the change in A. So what is the right option? B is the right option. Did you follow it? A d theta.
Yes, sir.
Huh. You can still get it using cosine. So let's try to get it. A squared plus a squared is 2a squared. So it was 2a squared into bracket 1 minus cos d theta. Cos d theta is 2 sine squared. 2 sine squared d theta by 2. Now it looks like you have to use the approximation. Just a second. Looks like you have to use the approximation here. See. Let it be 2a squared sine squared d theta by 2. Okay. And if I take the square root, what do I want? Acha, look, I know this formula. This one. Okay. Now, because I know that delta d theta is a small angle, and if I ever want to use it, I will make the following changes. Okay, the first change would be sine square d theta by 2 upon d theta by 2 squared. Okay, but that d theta by 2 squared is a deliberate inclusion. Okay, d theta by 2 squared is a deliberate oh sorry, I should not have written this as 2. This should have stayed 4. Okay, fine. So this is a deliberate thing, right? So it should be d theta by 2 squared again here, and because theta is small, this thing will go to 1. Do you understand this? Because theta tends to 0, sine theta by theta's limit is 1. So sine squared theta upon theta squared's limit will also be equal to 1. If you have not followed it, please tell me. Has everybody got this? The blue part?
Yes, sir.
You have. Okay, you got it. Very good. So it will be 4. Okay, it will simply be a squared into d theta squared. No? It will be a squared into d theta squared because 4 will get cancelled. And if you then take the square root, okay, if you then take the square root, what are you going to get? A d theta. And that is what you wanted, right? That is what you wanted. Delta I bar is a d theta. So you got the same result here, but you got it fairly quickly here. A d theta is approximately delta I bar, and here you kind of did it more mathematically and used the fancy cosine rule and still got the same. And of course you also use the limit there. Okay, fine. So you correctly understand the difference between mod of delta I bar and delta I. Both are scalars. Both these quantities are scalars. Okay, but one of them is basically vector first and then its magnitude, and in the second one it is just the change in the magnitude itself. Okay, without a change in length, so magnitude change will be 0.